So for this week, I have the relation of healthcare and the Internet of Things. So recap on last week, the article that I chose to go off of was the Internet of Things and Smart Healthcare Monitoring. So the Internet of Things, I read it so much that I kind of look up a definition for myself. But it's basically a system of computing devices, computer-like devices, that can transmit data across a network without the need for human interaction. And human interactions, like you don't need human-to-human interaction or human-to-computer interaction for this to work. My article last week was on a program or situation where you could have internet storage and processing of healthcare for healthcare applications. The proposed implementation of this sort of idea for my last week's article used metafog redirection and grouping and choosing sub-architectures to collect, secure, and store information in the cloud before moving to the Internet of Things for monitoring and processing. So from this, I looked into different smart sensors and the connection to the Internet of Things. So my first article is on wearable sensors integrated with the Internet of Things. This prototype solution, this article proposed a prototype solution to merge healthcare and the Internet of Things by using an Arduino Labellium kit, which is lower cost than most commercial sensors, and it also has simple integration. It provides either a wired or wireless communication interface, which a lot of the sensors out there do not offer. It also allows for a wider range of physiological sensors. These sensors monitor body temperature, respiratory rates, breathing, the electrical conductance of skin, which they measure via moisture level in the skin, electrical and muscular functions of the heart, as well as electrical and muscular functions of skeletal muscles. So once they set up this kit, they want to test the portability of this kit by using two different deployment methods, the Raspberry Pi 3 and a personal computer. So each of them then is implemented using a choreography machine, which functions as a sort of dispatcher, so it connects different modules together. This choreography machine relies on existing Microsoft libraries as well as existing Microsoft communication stacks. They then, once they ran them through, they compare the performance of both the Raspberry Pi and personal computer by way of latency in both the data transmission and the data loss. They found that the Raspberry Pi had significant delays compared to the personal computer. However, in the grand scheme of things, they found them to be negligible. So essentially they found that either setup for the portable devices was suitable for this type of data transmission. That's pretty much all the outlook they had on that. My next article focuses on smart sensors used in rural areas. So the article kind of focused on rural India. It's lacking in access to healthcare, smart sensor or not. They actually have like medical volunteers that come in instead of doctors because they don't have doctors available to come out. Current availability of these smart sensors relies on first of all it's expensive, but it also relies on fairly consistent wireless connectivity, as well as patient literacy, which rural India does not have the best connectivity. So it's not the most advantageous setup for smart sensors. So this article proposes a low-cost device and low-cost platform setup that can be used in multiple languages. The suggested platform combines multiple low-cost sensors, both invasive and non-invasive. So a non-invasive one would be like a smartwatch that you would have that would monitor your pulse. A medical interface unit and then an associated intelligent software, in this case the Health Awareness and Monitoring Platform, or HAMP. This software allows for patients to regularly track their health progress. It also has a multilingual application, so it works with many native dialects in rural India. Also, it allows the units to function with little to no internet connectivity. In case of an emergency, they actually connect to cellular connectivity to alert medical personnel via short text messages. Wi-Fi is, it does have the ability for Wi-Fi using the Internet of Things. They have a specific communication type available with Wi-Fi for low power devices with limited connectivity to Internet, which they use. They said they had super positive results from it. High percentages of patient approval in the 80s and 90% regarding patients' ability to use the platform and actually have it work for them, and user feedback, so how patients actually enjoyed using it for their medical purposes. My next article focuses on a database evaluation for fall detection. So it doesn't have a ton of Internet of Things relation, which is silly because Internet of Things was in the title of the paper, but I will discuss that in a second. This article proposes a benchmark database for fall detections. So they take information from 11 daily activities, so things that you would go about doing throughout a regular day, which include walking, running, sitting, standing to sitting, lying down, walking upstairs and walking downstairs, the lying down to sitting position, standing to walking, walking to standing, and sitting to standing positions. It also includes information on 4 different types of falls, so a forward, a backward, a lateral or sideways fall, and a supported fall. And then these are all based on a 9-axis sensor. So after they created this proposed database, they compared it to existing databases by way of 4 baseline algorithms. They use the artificial neural network, k-nearest neighbor, support vector machine, and Kernel-Fisher discriminant algorithms. They also had 3 different kinds of AdaBoost algorithms that were established and used, and these algorithms allowed for the reliability of the various databases to be evaluated. What they found is that when looking at information, this database was able to distinguish between a fall and a daily activity. So let's say you're wearing this 9-axis sensor, and you do a lot of sitting to standing, or reverse that, standing to sitting motions. So you're up and down in a chair all day. Well, they wanted to know if this database would be able to determine if you were falling backwards or just standing to sitting, and it was able to do that, so that was good. So they had a lot of positivity about the database that they created, and they said there's no current Internet of Things platform for this type of issue. However, this database and the information they collected would be a significant boost in constructing an IoT platform for this type of thing. My next article focuses on smart sensors, smart homes, and diabetes. So this one refers to the Internet of Things as the Internet of Medical Things, and they were focusing on an Internet of Medical Things implementation for the management of diabetic foot ulcers, or DFU. The article also discusses the connection between wearable sensors, the Internet of Things, and smart home devices. So the Internet of Medical Things would allow for patients to manage their chronic illnesses from home. They would be able to track their prescriptions using mobile devices, and then should they connect their sensors or whatever else to a smart home device, such as an Alexa or a Google equivalent of an Alexa, Patients will be able to order their medications, communicate with doctors, and adhere to a management plan more easily. They actually kind of wanted to test this as a way of compliance for patients to see if it would be easier to comply if you had this kind of set up with sensors in smart homes for complying to your treatment. There are current technologies available that could be connected to this type of system, and they include wearable monitors for wound healing and care. So this is a big one for the diabetic community. Sometimes you have like skin lesions or wounds, and it would kind of monitor how your wound is healing, and it would also give you a like a reminder, like time to change your bandage, time to do whatever. So that's a pretty big one for the diabetes aspect of this. There's also monitors for biomarkers for chronic health conditions, vital sign and skin condition monitors, and cardiovascular monitors, which is your heart. The article expressed significant concern over connecting this type of medical information with the Internet of Things. Security was a big issue that they raised, as well as patient privacy and patient compliance. Also battery life issues, so if you were using a smart sensor, you'd have to charge it, and how would you figure that out? However, they found that the benefits would certainly outweigh their concerns in this area, so if they can kind of figure out how to get over the security issue, then this would be a pretty significant step in the connection of healthcare and the Internet of Things. My last article is on a health prescription assistant and its security. So the health prescription assistant, or HPA, is put into place essentially to help patients adhere to doctor's recommendations. It serves as a go-between between doctors, patients, and certain databases. It has several subnetworks underneath it. So one subnetwork is the interaction between smart devices, sensors, kind of on the patient aspect, patient side. Another subnetwork is on the medical profession side, so doctors, nurses, and then a myriad of databases that connect to it also. And it basically compiles all this information for the patient and provides the best instructions, the best caregiver instructions for the patient to follow. The article even suggests connecting this prescription assistant to a smart home. For instance, it could control room temperature, room lighting, humidity in the room for optimal living conditions for that specific patient. So, for example, my uncle has Parkinson's disease. He used to live in Wisconsin. He now lives in Hawaii, and he's doing a ton better just from the change in weather. So if cold agitates arthritis, if cold agitates something else, this prescription assistant would be able to adjust the temperature in the room so the patient wouldn't necessarily have to worry about that kind of thing. The article then goes into significant detail about the security system for the HPA. It provides extensive background information regarding general security systems. It goes into specifics of a proposed security system, none of which I understood in the least bit. It was fairly interesting to kind of skim through, but I definitely did not understand the majority of it. But the article put way more focus on the security aspect than it did the health prescription assistant in connection to the Internet of Things. However, they found that their proposed system their proposed prescription assistant system and security system had really good positive results, and they expected it to be useful for researchers and in the development of future connections of healthcare and the Internet of Things. So, although some of my articles didn't fully connect to the Internet of Things and were lacking in some information regarding it, there was a lot of positive results from all of them regarding the programs and setups that they would like to connect to the Internet of Things, which is good. I do see a lot more of this happening in the future with the way healthcare is going. healthcare professionals, want to make it easier on the patient. They obviously want more information about patients because some patients don't give a lot of information. So I can see a lot more of sensor monitoring with that. I can see a lot of transitioning to Internet of Things and other online measures, simply to allow the patient to do more from home, so that you get more compliance and whatever else. So I definitely see this being kind of like the next step in healthcare, is moving to a monitoring Internet of Things relation.